One other story that's worth mentioning here is the Magdeburg Hemispheres. And this goes back to 1654 and a fellow named Otto von Geuricke. And I'm not sure if I'm pronouncing that correctly, but it's Geuricke. And he developed a vacuum pump which could suck the air out from a chamber. And he made these two hemispheres. So this was really just a large sphere, but it was cut in half. So imagine it's sliced down the middle, so the two pieces could come apart. And it was sealed up tight. And this was made of iron, very, very strong structurally. And it was, I think, a couple of feet across maybe. And some big metal pieces here that you could hook ropes to and pull. And there was a valve here, and he would hook his vacuum pump up to the valve, and it would suck all of the air out, or suck most of the air out. Now think about what's going on inside the hemisphere, or inside the sphere. Under normal conditions, there's air in the sphere and air outside the sphere. So I'll draw the forces that the air exerts on the sphere. So this is the pressure of the atmosphere on the outside of the sphere. And at the same time the air is on the outside pushing in, there's air inside the sphere pushing out, like this. And as long as the air pressure inside is the same as the air pressure outside, those forces are balanced. Well, when he hooked the vacuum pump up to it and sucked the air out, then the air inside is no longer there and no longer exerting the outward force. So with the inside evacuated, it would look something like this. Now he could never get a complete vacuum inside, but he could get enough of the air out that there was this very strong net inward force. The air inside was not exerting nearly as much pressure as the air outside. So the net force would be inward, as we've drawn here. And this force would tend to clamp the two hemispheres together. So even though there wasn't any glue or anything right around here, there was just an airtight seal, but there was nothing sticking them together, and they weren't bolted together, they weren't fastened together in any way. They would stick together with tremendous force just because of the air pushing on the outside. And he would actually hook up teams of horses. He would put 8 horses over on one side pulling one way and 8 horses over on the other side pulling the other way, and they were unable to pull the hemispheres apart. That gives you an idea of how much force there is. And if you think about the numbers, it shouldn't be too surprising. We said earlier that the atmospheric pressure is 14.7 pounds per square inch. So if you have these spheres that are a couple of feet across, you have hundreds of square inches. Each square inch is getting 14.7 pounds of force. So there's a tremendous force holding them together. And he demonstrated this in the town of Magdeburg, and that's where it gets the name, Magdeburg Hemispheres. And here's a picture showing what's going on. Down here on the bottom, here's some horses on one side, they're pulling to the right, and some horses on the other side, they're pulling to the left. And this is the device right here in the middle. It's really pretty small in the picture right there. And you can hardly even see the ropes and all that the horses are using to pull with. And up here, up at the top, these aren't UFOs or something coming down. That's just a diagram showing the hemispheres, the two halves, and you see them clamped together. And this is probably a seal of some kind, a rubber seal or something to keep air from leaking in after he pulled the air out with his vacuum pump. Here's a picture of him, Otto von Geuricke. It's close up. And one of the principles you should take away from this is that he demonstrated with this that things are not pulled by a vacuum, but rather they are pushed by the surrounding air. So when he sucks the air out of this compartment, this space in the middle, that the vacuum is not pulling things in. Okay, these things are not pulled together by the vacuum. Instead, it's the air around them that's pushing them together. And in the absence of a corresponding outward push from the inside, the surrounding force from the air can be overwhelmingly strong.